Pavesh, catch করতে পারবে? Good morning, sir.
Sir, very good morning. ওখানে একটু আনমিউট করা যাবে? Last 2 minutes. Sir, very good morning. শুনতে পাচ্ছেন না কিন্তু না, সব করা আছে। Sir, very good morning. No.
Sir, it is audible.
Very good morning, sir.
হ্যাঁ স্যার, আমাদের কথা শুনতে পাচ্ছেন?
হ্যাঁ, আমি শুনতে পাচ্ছি না। আমাকে দেখতে পাচ্ছ?
হ্যাঁ, আপনাকে দেখতে পাচ্ছি স্যার।
হ্যাঁ, তোমার এই টেলিফোনে কথা শুনতে পাচ্ছি, তোমাদের এমনি কথা শুনতে পাচ্ছি না, কারণ তোমরা মিউট করে রেখেছো।
না স্যার, আপনাকে খোলা আছে স্যার। আপনি
এখন শুনতে পাচ্ছেন স্যার?
না,
স্যার
শুনতে পাচ্ছি না।
হ্যালো।
হ্যাঁ, হ্যালো।
আপনি নিজেকে আনমিউট করে নেন স্যার।
করেছেন।
ল্যাপটপের সাউন্ডটা একটু বাড়িয়ে দেন স্যার।
দাঁড়াও। জুম কি করব এটা?
না, ল্যাপটপের সাউন্ডটা একটু বাড়িয়ে দিন স্যার।
ল্যাপটপের সাউন্ড
একটু বাড়িয়ে দিন। স্পিকারের জায়গাটা থেকে একটু বাড়িয়ে দিন।
শুনতে পাচ্ছ?
হ্যাঁ, আমরা শুনতে পাচ্ছি স্যার। আমাদের কথা শুনতে পাচ্ছেন?
হ্যাঁ, শুনতে পাচ্ছি।
আচ্ছা, ক্লিয়ার তো?
হ্যাঁ,
ক্লিয়ার শোনা যাচ্ছে?
হ্যাঁ, ক্লিয়ার শোনা যাচ্ছে।
আচ্ছা।
ভেরি গুড মর্নিং স্যার।
গুড মর্নিং। তোমরাও তো শুনতে পাচ্ছ?
হ্যাঁ, আমরা শুনতে পাচ্ছি ক্লিয়ার। ঠিক আছে স্যার, আমরা শুরু করতে চলেছি কিছুক্ষণের মধ্যেই।
তোমাদের তো 11টায় শুরু হওয়ার কথা ছিল।
হ্যাঁ, আমাদের কিছু ওই ইনঅর্গানাল পার্ট কিছু আছে, ভাইস চ্যান্সেলর স্যার আছেন। আমরা জাস্ট ইনিশিয়েশন করতে করতে আশা করি হয়ে যাবে, ওই টাইমটা চলে আসবে। ঠিক আছে,
একটু ওয়েট করে
আমরা একটু ওয়েট করছি, 5 মিনিট মতো ওয়েট করছি। হ্যাঁ
ওয়েট করো, নো
হ্যাঁ,
প্রবলেম।
ঠিক আছে ঠিক আছে, আপনি থাকুন স্যার লাইনে, আমরা ওয়েট করছি আস্তে আস্তে।
আমার পাওয়ার পয়েন্টও খোলা আছে।
আচ্ছা আচ্ছা, ঠিক আছে,
স্ক্রিন করে দেবো?
হ্যাঁ হ্যাঁ করে দিন, করে দিন, ফ্রন্ট পেজটা করে দিন।
করেছি, দেখতে পাচ্ছ?
হ্যাঁ হ্যাঁ চলে এসেছে, চলে এসেছে, ফাইন।
আরেকটু রাইটে করো।
এবার শুনতে পাচ্ছ, দেখতে পাচ্ছ?
হ্যাঁ পরিষ্কার, একদম।
দিব্যেন্দুদা, আমি অডিবল? Am I audible?
ক্লিয়ার ক্লিয়ার।
ওকে,
আমি একটু ইনিশিয়েশন করার পরে আমি তোকে হ্যান্ড ওভার করে দেবো কন্ট্যাক্ট দ্য প্রোগ্রাম। ওকে,
এই 2 মিনিট দাও, 2 মিনিট একটু খালি।
হ্যাঁ ঠিক আছে, আমি এখনো শুরু করিনি। ইয়ে কোথায় সৌমেনদা আসলে বলিস?
আসবে আসছে।
আমার স্লাইড দেখতে পাচ্ছ?
হ্যাঁ একদম
দেখা যাচ্ছে স্যার।
প্রথম স্লাইডটা,
হ্যাঁ ফার্স্ট লাইট, নিউট্রিয়েন্ট মাইনিং ইন ইন্ডিয়ান এগ্রিকালচার, ফুড সিকিউরিটি ভিসাভিস সয়েল হেলথ ইস্যুস। ঠিক আছে, এটা প্রজেকশনে থাক, আমরা আস্তে আস্তে শুরু করছি। স্যার বলছি আমাদের প্রোগ্রামটা কি আমরা ইউটিউব লাইভ করব? আপনি যদি পারমিশন দেন তাহলে আমরা করতে পারি ফর ওয়াইড সার্কুলেশন।
নিশ্চয়ই।
ওকে ওকে, থ্যাংক ইউ, থ্যাংক ইউ। ওকে,
তুমি দেখতে পাচ্ছ তো আমাকে দিব্যেন্দু?
হ্যাঁ দেখতে পাচ্ছি স্যার।
আমিও দেখতে পাচ্ছি।
আচ্ছা আচ্ছা,
তোমার পাশে আরেকজন বসে আছেন,
স্যার চিরন্তন।
ও চিরন্তন, আচ্ছা আচ্ছা আচ্ছা, ভালো আছো?
এই তো স্যার আপনার আশীর্বাদে।
থ্যাংক ইউ, অল দ্য বেস্ট। শুভ বিজয়া।
শুভ বিজয় স্যার।
তোমরাও শুভেচ্ছা জেনো।
About to start. Avasina.
Yes, sir.
It is audible, clear?
Yes, yes. Am I audible?
Yes, yes. Clear.
Okay.
বলার স্যারের বলা
দিব্যেন্দুদা,
হ্যাঁ হ্যাঁ বল।
আমরা বাদ দিয়ে আর কি কোনো অন্য ইউনিভার্সিটির হেড বা কেউ আছেন? একটু দেখে নাও, আমি তো এখান থেকে দেখতে পাচ্ছি না।
অ্যাকচুয়ালি টাইমটা যেহেতু 11টা থেকে দেওয়া আছে তো
আচ্ছা আচ্ছা, ঠিক আছে, ওকে ওকে।
ওই 5-10 মিনিট আগে হয়তো জয়েন করবে, এমনি জয়েনিং হচ্ছে আস্তে আস্তে, অনেকে জয়েন করছে। হ্যাঁ
ঠিক আছে,
দেখা যাক হয়ে যাবে। না জাস্ট 5 মিনিট ওয়েট করছি যাতে স্যারের টকটা ঠিক 11টার মধ্যে শুরু হয়ে যায়।
আর ডিন পিজিএস কি অনলাইন ইয়ে আছেন, থাকবেন?
উনি এখানেই আছেন।
আচ্ছা, ঠিক আছে।
উনি এখানেই আছেন।
আর বাকি কোনো ডিন আছেন কি, মানে হর্টিকালচারের ডিন কেউ অফিসিয়েটিং কেউ আছে?
হর্টিকালচারের টিমরা অনলাইনে থাকতে পারেন, আমরা আমাদের অ্যাড্রেস করে নেব, ঠিক আছে? কাস্টমারি অ্যাড্রেস আমরা করে নেব। ডিনস ডিআর অনেকে হয়তো অনলাইনে থাকবেন। হ্যাঁ
ঠিক আছে, ঠিক আছে।
যারা আমাদের প্রোগ্রামের সঙ্গে জড়িত আর কি, ডাইরেক্টর অফ এক্সটেনশন এডুকেশন, ডিএসডব্লিউ এবং আমাদের মেম্বার্স। আস্তে আস্তে স্যার আমরা এবার শুরু করে দিই আস্তে আস্তে টাইমটা এগিয়ে আসছে with your kind permission and permission with the Vice Chancellor. Okay, good morning everybody. First of all, I extend my heartiest regards to Honorable Vice Chancellor Dr. Chirantan Chattopadhyay and our very respectable Professor Dr. Saroj Kumar Sannal, who was our teacher in Bidhan Chandra Krishi Vishwavidyalaya and our former Director of Research and former Vice Chancellor Bidhan Chandra Krishi Vishwavidyalaya. He is with us. We cordially invite our speakers, especially the students for which this webinar has been set up, and also the other participants from different universities will be joining very soon with us. We have with us our deans of the faculties, Dean PG Studies, Director of Research, Director of Extension Education, Dean Students Welfare, my colleagues, and who are with us for framing out all these programs, which will be tenured from 5th November till 11th December 2020 phase-wise. And today is the first day, and the program is being inaugurated by our very respectable teachers, Professor Saroj Kumar Sannal, and we have other eminent speakers from India and abroad also. And we have already circulated the list of the speakers. The very basic program of this webinar is that to highlight some of the issues and the gaps that we often face for our soil research and education system. And it has been obtained that adopting sustainable development goals as coined by the United Nations as SDGs is not very effective due to some reasons. And we have to find these reasons because soils, which is the most natural and finest research, is linked with these land-related disciplines. And we have to nourish it by any means. As we are conceived with different branches of the soil science, starting from the soil chemistry, soil fertility, soil biology, soil physics, soil pedrology, we have observed that there are so many link up in between. Still, there are some issues that needs to be highlighted, issues related to nutrient mining, soil health related issues, then groundwater pollution, and there are different management practices related to agriculture, for instance, conservation agriculture, etc., etc. But we have observed that framing these researchable issues needs a resonating for framing the policy cycles. It is because of that, either in the form of the collaborative research or interdisciplinary approach, etc. That means what was earlier back in 10 to 20 years and what we are now at present, there is a shifting paradigm from the traditional system to the cross-cutting technology in the agricultural scenario. So based on these perspectives, we have to frame the strategic and the fundamental research issues so that some kind of innovative models be set up in the agricultural systems. And using this modern information, which will obviously improve the results in the inter and transdisciplinary studies such as food security, water scarcity, climate change, biodiversity loss, and obviously the health threats. So soil science, as it has a very vast domain, we know, and is linked with so many other subjects also. And I think this webinar type of platforms is very useful for us, specifically those who are related to these subjects and particularly the students. So based on that, we have to think about the issues that will be addressed by our eminent speakers. And we have designed that topic in that way, specifically for the students studying under the postgraduate and the undergraduate sections. But the one thing that we have to keep in our mind, that translating action to be taken into action. That is the very, very pertinent point, so that we can nourish these most precious resources on earth like soil. And with this proviso, I think this series of lecture will give us an insight to the students, the faculties, as well the other sector also. And I again extend my gratitude to all the speakers and who will be attending this and delivering their very reliable and resourceable speech in these issues. And I wish the success of this program, and thank you once again. Now I hand over to conduct the program to our convener, Professor Avas Kumar Sinha, for the subsequent programs to follow up. Professor Sinha, now it is hand over to you. You please continue.
Thank you, Professor Dibyendu Mukhopadhyay, our respected head and dean, faculty agriculture. So before welcoming our guests, I would like to first of all extend my pranam to my respected Vice Chancellor and our respected Sir, Professor Saroj Kumar Sannal Sir. Sir, I am very privileged that Honorable Vice Chancellor Sir, respected Professor Saroj Kumar Sannal Sir, the different dignitaries or the officers of our university, Director of Research, Director of Extension Education, Dean Students Welfare, Dean PG Studies, and all other Dean faculties, and respected head of the departments, and my colleagues and my dear students. It is a great pleasure to welcome our Honorable Vice Chancellor to the webinar, Contemplating Soil Research and Education, a Way Forward. Sir, we are very grateful that you could spare some time from your busy schedule. I, on behalf of organizing committee, is privileged to welcome Professor Saroj Kumar Sannal Sir, who has been teacher of almost all the faculties of this Vishwavidyalaya in our department. Sir, we are all honored to be present in this webinar to hear from a person who is one of the stalwarts of the soil science and agriculture chemistry. I also welcome all the functionaries, Director of Extension Education, Dean PG Students, Deans of the Faculties, Dean Students Welfare, and nonetheless our Director of Research, who also belongs to the Department of Soil Science. I'm very happy to welcome to HOD Soil Science and my fellow colleagues and my beloved students to this webinar. So this webinar, Contemplating Soil Research and Education, a Way Forward, which has been further subdivided into themes related to all the aspects of soil science and some portions of environmental science. The webinar, which starts today, would continue up to December 11, 2020, and we have requested eminent speakers from different national and international institutes, and we are fortunate enough that they have agreed, and although only one of the eminent speaker is present on the day, but I, on behalf of organizing committee, formally welcome all the speakers to this webinar. We are very proud that during this entire period of the webinar, the soil science department would be able to gain knowledge and interact with the stalwarts, which will be a way forward for the education and research for this department and of course the university. So sir, I move to next phase where I will request our respected Dean Postgraduate Studies to give his remarks in this webinar. Sir, Dean PG.
Honorable Vice Chancellor, other distinguished personalities, deans and directors of this university, the respected speakers of the online lecture series, participants of this August virtual gathering, persons from press and media, my fellow colleagues, heads of the departments, and my beloved students. Good morning and a very hearty welcome to you all in the online lecture series in the light of Contemplating Soil Research and Education, a Way Forward, organized by the Department of Soil Science and Agricultural Chemistry, Faculty of Agriculture, Uttar Bango Krishi Vishwavidyalaya, on and from 5th November to 11th December 2020 under 5 different theme areas. I'd like to thank you all attending the program for gracing the occasion. Uttarbanga Krishi Vishwavidyalaya, a state agriculture university of West Bengal, established on 1st February 2001, is responsible to cater the agricultural education, research, and extension-oriented activities throughout the North Bengal region of West Bengal, feels it appropriate to use the virtual platform to continue the activities under the COVID-19 pandemic situation. As a result, the Department of Soil Science and Agricultural Chemistry comes out with this online lecture series in addition to the program organized by the NAHEP team of Uttarbanga Krishi Vishwavidyalaya. Today is the inaugural day of this program. A number of thought-provoking lectures will be delivered by eminent speakers in this program, which will ultimately develop a panorama of the history and development of soil science research and education in India till date. Today, the first lecture will be delivered by Professor S.K. Shannal, our honorable teacher and a respectable fellow. It goes without saying that any adjective becomes smaller in front of his wisdom. We all are very much eager to hear from our honorable teacher, Professor S.K. Shannal. In spite of his extremely busy schedule, sir gave his kind consent to share his experiences with us using this virtual platform. I think which will become very much helpful for a better understanding about the subject. I hope the sweet memories of this entire program will remain afresh in our mind for a long time and will become helpful in our future activities. Thank you. Thank you all.
Thank you, our respected Dean Postgraduate Studies. I will now request our Honorable Vice Chancellor, Sir, to address this webinar.
Very good morning to all of you, our very respected teacher and former Honorable Vice Chancellor of Bidhan Chandra Krishi Vishwavidyalaya, Professor Sharaj Kumar Shannal, sir, and all other speakers of this webinar series, the deans and directors of the university, respected teachers, and my dear students. This is a privilege for me to welcome one of the most celebrated teachers that we have enjoyed in our lifetime. And that's Professor Sharaj Kumar Shannal. Today's students are fortunate that you will be listening to the stalwart. We have been pampered by such people. And as he is going to speak to us on nutrient mining in Indian agriculture as related to food security and soil health issues. And in the webinar series, we have other speakers as well who are celebrated too in their own fields, and they will be talking on different subjects, different theme areas. And the backdrop of the entire webinar is soil research and education. Sir, we heartily welcome you, sir, to this webinar series on my personal behalf, as also on behalf of the fraternity of Uttarbanga Krishi Vishwavidyalaya. I heartily welcome you to the webinar series and today's lecture from you. Sir, this topic of nutrient mining really bothers me, although I am not a soil scientist, but the way we have been doing the Indian agriculture and cultivating, particularly in the Indo-Gangetic plains, and also in several other parts of the country, particularly the exhaustive crops like maize that is gaining popularity over time, and so also so many other cereal crops. And we are not appropriately rotating them, in my view, to sustain whatever is being mined out. Certainly has been bothering me for quite some time. And I really like to congratulate the head of the Department of Soil Science and Agriculture Chemistry, as also the Dean Faculty of Agriculture, and all the members of the organizing committee for setting up this kind of webinar series so that we can be a little more enriched and discuss on this important issue. So far as the backdrop of the soil research and education is concerned, as I was just now mentioning, that we enjoyed the stardom of teachers when we were students. This has given us a confidence, at least, to face any another knowledgeable person and sit and discuss for a while. But what we really find with a lot of botheration is that when we are placing advertisements for recruitment, over number of advertisements, we are not even getting ample number of applications so that we are confident enough to call for an interview. That is the situation that is happening even in the subject of soil science, in the subject of agronomy, and such subjects. Sir, situation has, when somebody comes and says, you will agree that when somebody comes and says that you might have called 10 people or 20 people, but sir, believe me, I am the best of the lot. That also is good to listen, and it gives the people also on the board a lot of confidence that we have a good bunch of candidates. But when somebody comes and says, sir, please keep in mind, I too am a candidate and you kindly try to consider my candidature, that brings a lot of shame with us. And this kind of situation in subjects like soil science and agronomy, in this backdrop, is a matter of concern which I thought I should flag. And why this is the situation we are facing today. Where lies the problem? I think through the different subjects that we will be discussing in the webinar series and learning through for the nutrient mining related to food security and soil health issues, we also need to also address the issue of human resource development so that when we leave the platform, we leave it to a dependable lot who can take the challenge ahead. We raise the bar and the future becomes brighter. With that, I once again welcome you to today's lecture, sir, and we keenly look forward to listening to you on this important subject. Thank you so much. Over to you, sir.
Thank you very much, our Honorable Vice Chancellor, sir, for his brief remarks and, of course, very informative. He has been always encouraging us in conducting these types of programs. So before going to our main agenda of this webinar, where our respected sir will give his lecture, I will request our head of the department to please introduce Professor S.K. Shannal, sir.
It is somewhat very difficult to sum up the CV of such a personality like Professor Shannal within a very short period of time. Still, I want to highlight some of the credibilities that he has earned during his lifetime of Dr. Saroj Kumar Shannal. He has, to his credit, a brilliant academic career with undergraduate, postgraduate, PhD, and postdoctoral studies at highly reputed institutes securing top positions, namely the Presidency College, affiliated to the University of Calcutta, Indian Agricultural Research Institute, IARI, New Delhi, University of Cambridge, United Kingdom, and the International Rice Research Institute, Philippines. Professor Sannal was actively involved in the teaching at Bidhan Chandra Kishi Vishwavidyalaya. He was as well the Director of Research during 2005 to 2010 and the former Vice Chancellor from 2010 to 2012 of Bidhan Chandra Kishi Vishwavidyalaya, West Bengal. He has guided 26 research fellows for their PhD degree program from different universities, namely BCKV, University of Calcutta, Jadavpur University, and Kalyani University. Dr. Sannal was an adjunct professor in soil science and agriculture chemistry of the IARI, New Delhi, and Bihar Agriculture University, Sabod, Bhagalpur. Dr. Sannal is presently acting as the member, Scientific Advisory Committee, Toklai Tea Association, Jorhat, Assam, Chairman, Natural Research Management Consortium, Research Advisory Committee, National Tea Research Foundation, Tea Board, Calcutta, to name a few. He was the president of the section of the Agriculture and Forestry Sciences in 92nd sessions during 2004-2005 of the Indian Science Congress Association held at Ahmedabad, Gujarat. His scientific standing in the country was honored with awards and laurels, as well as fellowships of several national academics and learned societies, such as National Academy of Agriculture Science, Indian Society of Soil Science, West Bengal Academy of Science and Technology, etc. As a researcher, Dr. Sannal has successful in securing funding support from ICAR, UGC, CSIR, PPIC, now it was IPNI, Department of Agriculture, Education, Science and Technology of the Government of West Bengal, State Water Investigation Directorates, Government of West Bengal, etc. His research work spanned in diverse, locally and globally relevant areas such as soil organic matter dynamics, including metal-humic interactions, phosphorus and potassium dynamics in soil crop system, transport processes in soils and clays, integrated nutrient and water managements, and to name a few. There are so many fields that he has thrived well in the research program, and he has nearing 160 peer-reviewed research papers of national and international repute. During his research career, Dr. Sannal also acted as the principal investigator of multidisciplinary and multi-institutional teams of researchers in addressing the researchable issues under funding from ICAR, New Delhi, as well as other funding organizations. Dr. Sannal was appointed by the ICAR as a member of the sectoral committee of the Accreditation Board of ICAR on governance and personal and financial policies during 2013 to 2016, a member of the peer review team for accreditation of the Indira Gandhi Krishi Vishwavidyalaya, Raipur, Chhattisgarh, and a member of the ICAR constituted committee for working out the minimum standards of higher agriculture education for establishing a college in the state agriculture universities or deemed universities or central agriculture universities during 2013 to 2014. He was also the members and chairmen of the quinquennial review teams, QRTs, appointed by the ICAR. And Dr. Sannal was invited in 2011 by the ICAR to act as a member of the working group on agricultural research and education for the 12 5-year plan. He has, to his credit, with 35 years of teaching skill and enjoyed teaching, spanning in the different domains of the soil science in different universities like University of Calcutta, Bidhan Chandra Kishi Vishwavidyalaya, Jadavpur University, Indian Agriculture Research Institute, to name a few. He has evaluated the PhD theses of several agriculture institutions, including IRI, New Delhi. I have cut short his CV for the time constraint. There are lots to read out, but I think this is quite sufficient for the participants as well as the faculties. The personality like Dr. Sannal will be delivering his lecture now on. Now, thank you very much, sir, and I cordially invite you to deliver your talk in this webinar. Now, over to convener, Professor Sinha, please.
Now, thank you, Professor Dibyendra Mukhopadhyay. Now I request our respected teacher, Professor Sharoj Kumar Sannal, to deliver his lecture in this webinar.
Thank you. Thank you. And I'm happy that the Honorable Vice Chancellor, Professor Chirantan Chattopadhyay, is present, and also several deans and directors of the university, Uttar Banga Krishi Vishwavidyalaya. And I'd like to thank the university authorities, particularly Professor Dibyendra Mukhopadhyay, Dr. Abhas Sinha, and their colleagues for having invited me to deliver this lecture. With this, let me pass to the lecture itself. The title you can already see: Nutrient Mining in Agriculture, Food Security vis-a-vis the soil health issues. Now, what are the issues of concern in regard to this food security? At the current rate at which the population is increasing, it is necessary that additional 5 to 6 million tons of food grain must be added each year so as to keep pace with the ever-increasing population of the country. But the total cultivated land has either remained stagnant or has declined. It's about 140 million hectares for several years together, and is also shrinking because of the diversion of the agricultural land to accommodate non-agricultural uses like industrialization, urbanization, so on and so forth. Therefore, to have the quantity of food that will be necessary to cater the needs of the population in years to come, the productivity increase is the only viable option. But then that is beset with difficulties, because we know that there has been a severe decline in the total partial fertilizer factor productivity as well as total factor productivity in important crop growing regions of the country. And I will speak a little more about it a little later with the help of some actual data. But this total factor productivity and partial factor productivity decline leads to the decline in the native soil fertility. Then if the fertility goes down, obviously, the productivity will be less. And on the top of it, in northwest and part of the west of the country, the Punjab, Haryana, western Uttar Pradesh, and so on and so forth, there are nutrient acquisition efficient crop cultivars are being introduced. The the hybrid rice and wheat and so on and so forth. But the fertilizer rate is kept more or less at the same level as for the high yielding varieties. Now there is more nutrient removal then by this nutrient acquisition efficient crop cultivars, and that will further lead to the decline of the soil fertility. On the other hand, nutrient replenishment in crops has remained more perception based rather than being driven by scientific understanding. Now, what is nutrient mining? It's simple. The nutrient mining is a negative balance between the nutrient input and output, and it results when the crop nutrient removal as well as losses to different avenues exceeds what is added to cater for the entire loss, including the crop uptake and the losses to several things. And a negative input-output balance as a result of this in soils will lead to the depletion of the soil fertility, and that will eventually limit the crop yield. Now this little equation here, a form of equation, suppose B is the concerned nutrient in a rice wheat belt, for example in IGP, in the Gangetic Plain, very important cropping sequence in an important crop growing zone. The terms you have on the left-hand side of this red dotted line are the input factors, and those on the right-hand side are the output factors. Now the input could be from the irrigation water multiplied by the effective efficiency. Because as you know that particularly the irrigation facilities in Punjab and Haryana where the lighter texture soil is there, so there will be some percolation loss. So whatever nutrient will be added by the irrigation water, that must be multiplied by an efficiency term, because all the nutrients that is brought in together by the irrigation water will not be there. Much of it will pass to the groundwater through percolation. Then crop residue multiplied by effective efficiency. Then rainfall the same way multiplied by effective the efficiency, and soil nutrient supply multiplied by the corresponding efficiency. Because we know that there only a fraction of the soil nutrient is in the available pool. Then on the right hand side, you have the, for rice wheat belt, the grain yield of rice multiplied by what we know as the reciprocal of internal efficiency. As we all know that the internal efficiency is the amount of grain produced, or the amount of the economic produced per unit uptake of the a particular nutrient. So if you take the reciprocal, then that becomes the actual nutrient loss. So this is for rice, and the next term is for wheat. So this is the balance, nutrient balance kind of equation. So this must be filled up by additions from somewhere, right? Then we come to the next slide. These are the, I mean, what I talked about just now, it's shown here. Next is the soil quality, or what is known as soil health, is most often defined as the capacity of the soil to function. Now, if the production has got to be sustained in terms of the crop yield, then a vital indicator, soil health is a vital indicator. Soil health comprising all kinds of properties of soil, for example, the physical, chemical, as well as the biological properties. And the limitation imposed by the inadequate nutrient status would strip the soil of its capacity to function or perform. That means the soil quality will go down. And adequate availability of essential nutrients, the soil, will be critical for sustaining such yield. Now, kind of, I was telling you that the declining, the partial factor productivity decline, this is a very explicit graph in which you can see that the crop yield has remained more or less constant between, say, 1970 and 2010 and further onwards. But the fertilizer contribution is given by the dotted line. So these are the fertilizers which are responsible to bring about the increase, a given amount of yield. So this dotted line, these are the fertilizer contributions. But the fertilizer that is necessary to obtain this kind of yield is gradually increasing from 1970 all the way from to up to 2010, and it is still going down. And as a result, the same amount of fertilizer produce the same yield, more or less same yield, because the yield is more or less constant. Therefore, there is a severe decline of the partial factor productivity. Now, let us examine the nutrients which are more prone to mining. Let us first of all consider nitrogen. Now, we know that the nitrogen is very mobile, and the subtropical climate which is prevailing in our country, as well as tillage, makes nitrogen more prone to loss. But we do not talk about nitrogen mining, because so much nitrogen is added by the farmers to the field. We all know that the fertilizer scenario is a mostly nitrogen-driven scenario. So we do not talk about nitrogen mining, because there is so much external application to fertilizer and manual sources rather than, and we do not depend for nitrogen on the native source. Even if there is a loss of nitrogen because of subtropical climate, mobility, and tillage, but then so much nitrogen is added so that it more than compensates for the kind of losses of mobility and so on and so forth. Therefore, we do not talk about nitrogen mining. So here it's a yield gain based approach. to obtain a certain yield, how much of vegetative matter has to be produced, vegetative plus reproductive matter, of course. So that's the kind of yield. Uh, so the yield gained approach is followed to add the nitrogen. And as you can see, the nitrogen response is about 2.6 ton per hectare over a large number of 141 locations in the Indo-Gangetic plain. Next comes phosphorus, the nutrient. When you examine the mining issue, we talk about phosphorus. Now we all know that the phosphorus is an immobile nutrient, and there is a general consensus that for phosphorus, soil acts as a kind of bank for phosphorus. Phosphorus remains in the soil in several forms, but mostly in forms which are rather sparingly soluble or altogether insoluble. And therefore, to meet the in-season demand, when you sow a crop, for example, there is not enough phosphorus present in the available pool. So we have to add that kind of phosphorus so that the crop doesn't suffer. And therefore, for phosphorus, even though we have large amount of phosphorus buildup, but that buildup is mostly in the inaccessible form by the plant roots. And as a result, we have to add some phosphorus initially so as to meet the immediate need of the crop. So here yield gain by maintenance approach is necessary. And at the bottom, you can see that the phosphorus response in wheat across 141 locations in the Indo-Gangetic plain, and that is about a ton per hectare. By the way, I forgot to tell you that this nitrogen response was also in wheat, and there the mean response was about 2.6 ton per hectare. Now let us come to potassium, the other major nutrient, and to examine whether it is important as far as the nutrient mining is concerned. Now, we all know that the presence of mica, the litic minerals, for example, as well as feldspar in soils provide an abundant in situ source of potassium. Furthermore, potassium ion is entrapped by the negatively charged interlayer space of soil clays, and therefore it is prevented from being lost. But still, nutrient mining is most relevant for potassium because of the low awareness, low application rates, and excessive removal from soils. Just a while ago, I think Professor Dibyendu Mukhopadhyay, Dr. Abhas Sinha was telling about maize. As we all know, maize is potassium responsive crop. And there are several crops, the horticultural crops. Horticultural crops, for example, the fruits and vegetables, remove potassium in quantities which exceed the quantity of nitrogen that they take. And in other cases also, for example, cereals, particularly for potassium, the nitrogen intake, uptake and potassium uptake is more or less the same. But the potassium application is extremely poor, extremely low. One reason could be that we do not have the potassium deposits in the soils of in India, and as a result, potassium fertilizer has got to be imported, and therefore potassium is costly. And there is also a lower degree of awareness. Incidentally, I would like to mention that I would refer to that little later. Well, when you come, we shall talk about it. Now, the potassium mining is important because of low awareness, low application rate, and excessive removal from the soils, as I said, by the vegetables, horticultural crops, and also several other crops, including maize. Therefore, here fertilizer based on yield gain and maintenance approach is required. Now, let us see the input, output, and balance of NPK in Indian agriculture. Now, you can see that between the period of 1950s to current time, there is hardly any potassium which is added compared to nitrogen. Even phosphorus addition is either comparable, it's more in all the cases. And therefore, as I was telling you, that the Indian fertilizer application scenario is overly nitrogen driven. It's about, say, 80% or thereabout. Another important slide is this one. Now, along the positive direction of the y-axis, there are the input parameters, and along the negative direction of the x-axis, these are the output parameters. Now, what are the input parameters? These are input and these are output. The crop, the deposition, fixation, because that remains in the soil, and also the readily available nutrient like fertilizer, and also slowly available nutrient from the manure source. And the removal are this way. And this is the uptake of the by the new crops, nitrogen uptake, for example, and nitrogen losses through several other things. But the balance is, if you subtract these two, it becomes positive. Similarly, for phosphorus also, you have this fertilizer and the manure, and the phosphorus uptake is this much, and there is hardly any, as I told you, phosphorus is very immobile, hardly there is any loss through other avenues. And as a result, the balance is again positive. So much is added and so much is removed. But let us come to potassium. The potassium addition is very low, as I just shown you. This is the fertilizer, this is manure, and this is deposition. But the potassium removal, as I told you, that it is almost equal to nitrogen or more than nitrogen in almost all the crops, particularly for the horticultural crop. For example, banana, it binds potassium in very large quantity. And as a result, when you talk about the net balance, this is positive. Net balance here, this is positive, but the net balance here is negative. So much so that this negative balance is more than the addition of the two positive balances. So there is an overall nutrient mining in the Indian soils. And if there is nutrient mining, the fertility will go down, and therefore the productivity will not increase. The area under cultivation is not increasing. Productivity has got to be increased. But these are the stumbling block to increase the productivity. There are other causes also. I'll come to that little later. This also shows the micronutrients. Unfortunately, I do not have a slide for the secondary nutrient, but you will see. So except for zinc, you can see that the iron, manganese, boron, and copper, the balance, nutrient balance is all negative. These are also then mined. They lead to decline of soil fertility. But you cannot afford to have fertility declining. Otherwise, the productivity cannot be increased. So hence, this is important that the nutrient exact balance is maintained in the soil crop system. Now, what is promoting nutrient mining? This is a farmer's fertilizer practice, which is based on perception and is also influenced by his neighboring farmers, the peer influence. And as you all have already seen, that it is overly nitrogen driven. Now, there are other formulations also. 4:2:1, so-called ideal fertilizer ratio, nitrogen, phosphate, potash. Soil test crop response is also talks about the contribution from the soil source. It doesn't say how much will be returned back to the soil. The same is the case with state recommendation. Incidentally, well, I'll come to it a little later. Therefore, in these approaches, we shall see that the nutrient mining aspect is not properly integrated. And crop residue removal from the farms, or in the northern part of the country or northwestern part of the country, the residues are often the straw and other things. After the economic produce is harvested, is burned. That leads to global warming because it produces carbon dioxide, and a large source of repository of nutrient is lost, because if the straw and other vegetative part at the senescence is incorporated into the soil, there will be nutrient coming from that. But there is removal of crop residue. Why? Because in our country, for example, what is the other competitive uses of crop residue? For example, jute stick. These act as a firewood, for example. This is fuel. We do not have adequate fuel supply in this country, and as a result, they're also used for fuel. Not only that, for the cattle feed, the residue, the straw, for example, is an important crop residue, and that is removed. And this is the major source of nutrient offtake from the field. Now I come to 4:2:1 in state. This is the so-called, I'll say why I'm calling it so-called ideal ratio, nitrogen, phosphorus, and potash. In this state of West Bengal, 2:1:1 ratio is followed, or any other ratios. Why there should be a ratio in the first case? Now, how all the crops will need fertilizer in the same proportion? For example, when you go to horticultural crops, obviously, if you add only fertilizer 4 times nitrogen and compared to that only 1 time potassium, there will be always a mining, and that will adversely affect the soil fertility. Similarly, any ratio. For example, balanced fertilization, as I told you, is often accepted as nitrogen, phosphorus, and potash as 4:2:1. But this is really surprising that potassium is removed in so large quantity, but is added in very small quantity. And the validity of such a uniform prescription across the board without taking into account the inherent features of the soil and the crop uptake, or the type of the crop grown or cropping sequences, that has been questioned at different forums. As you can see in different countries, it's not that a kind of same ratio is followed everywhere. There cannot be an all-pervading ratio which can justify the concept of balanced fertilization. And next slide. Now we see even this is the kind of 4:2:1 kind of potassium application quantity, which is which itself is low, because only 4 times nitrogen, for 4 times of nitrogen, only 1 time of potassium is applied. So that itself is low compared to the potassium uptake and its losses through several avenues. The farmers actually use the red one. They even do not use as much as potassium, which is predicted by 4:1, which itself is low. Farmers use even lower. Now you can see that there is a sudden dip here around 93, 94. And then another dip in 2009-10. You will remember that the phosphorus and potassium fertilizer was decontrolled in 1992-93. So there is that is reflected in the immediate fall of potassium application. Similarly, the nutrient-based subsidy 2010 by the government, that also led to potassium decline, because it gives the neem-coated urea a very low subsidy and almost nothing for potassic fertilizer, or for that matter, phosphatic fertilizer as well. This is taken from our former colleague, Dr. Kaushik Majumdar. He is now the Director General of African Plant Nutrition Institute based in Morocco. Now, bridging the yield gap. We know that the average crop yields of India are only a fraction of the targeted yield levels. Even if you targeted yield, if you consider, you compare the situation between China and India, where China, for example, you may have easily 5 to 6 tons per hectare of rice. Here the average will be about 2.1 to 2.5 tons per hectare. So the yields are low. Even that even in that there is an yield gap. For an example, if we are able to increase the food grain yield by 1 ton per hectare in two states, namely Bihar and Uttar Pradesh, they can alone increase the grain production by 25 million ton annually. And the factors that cause this yield gap, why the soils are not able to, or the situation is not able to achieve the targeted yield, is a function of several factors like crop, cultivar, soil, crop, production inputs, including seed and nutrients, and poor water management, as well as level of crop husbandry. Next is, now when you talk about nutrient, we must talk about the water, the irrigation water. Because as we know that the fertigation, for example, is an important avenue through fertilizer application, as well as there are other avenues also. Now we can see that in the year 1900 and this is with 2000, you see this is the 7% is used for energy, and for industry, this is the industry, that is the 5%, and the domestic is also around 5%. But by 2025, and as we are already seeing, because we are approaching 2025, the industries are increasing. The power sector, for example, the electricity generation is also increasing, and domestic is remaining more or less the same, the domestic supplies. The scenario will be double, from 7 to 15%, from 5 to 11%, the industry and the energy, and therefore the fresh water means the surface water plus the groundwater, where 83% of groundwater share was used, for example, in the fertilizer in agriculture to take care of the irrigation. But that will decrease to 69% only because of increasing demand by the industry and the power sector. And not only that, this industry or the power sector, thermal power plant, for example, it takes in water, but it discharges that water, whatever water is discharges, that is in highly polluted form. So not only the scientists in 2025 will have to contain themselves with a decreased share of fresh water, that is groundwater plus the surface water, but they will have to contain themselves also with the polluted water, how to manage it, clarify it before it put to use for crop irrigation purposes. Otherwise, if there is, for example, it is polluted with heavy metals, there will be heavy metal intake by the crops, and that through the economic produce will come to the human soil, crop, animal, human continuum, and that will lead to health hazard. Next slide. This slide shows the apparent nutrient balance sheet for different crop sequences involving legumes at two locations, at Pantnagar and at Madhipuram. Now, of course, rice wheat doesn't have any legume, the other ones have. Now, if you see the last column in brown color, that shows the potassium balance. It is highly negative. It is also negative in some of the systems like rice, chickpea, maize plus cowpea as intercrop, the fodder. It is also negative, -142. But in many cases, it is positive, and for phosphorus, it is positive everywhere. Now, this slide gives the nutrient depletion factor. Nutrient depletion factor is the output, how much is taken away, to the input ratio. This is rice wheat system, which is practiced under best management practices at several locations: Sabur, Ranchi, Ludhiana, Palampur, Arispura, and Faizabad, Kanpur, Madhipuram, Varanasi and Pantnagar. You can see that if the ratio is more than 1, then there will be obviously the nutrient mining. Now, the phosphorus for phosphatic fertilizer in 6 locations out of 10, it is more than 1. That means there is a bit of phosphorus mining as well. But when you come to potash and sulfur, it is negative everywhere. It is negative. I mean, it is more than 1 everywhere. You see, these are the ones. And when we talk about the depletion of the soil nutrient from the soil reserve, you can see the red mark, potash, is very high. Sulfur also, there is a negative nutrient mining. Next slide is, where do we go from here? I forgot to mention earlier that the applying fertilizer in any particular ratio or in any particular formula goes directly against the principle of precision farming. In precision farming, the soil variability, for example, is taken into account. Therefore, it is not that in every kind of soil you apply the fertilizer in the same ratio. So that is against the concept of site-specific nutrient management as well as precision agriculture. So where do we go from here? The imbalance that we have been talking about so far, some form of balance, which is 4:2:1, 2:1:1, none of them is satisfactory, or site-specific nutrient management, whether it is good enough, we do not know. Let us take a look at the variability of the properties. This is a study site at Murshidabad, for example, in West Bengal. You see in the last column, the CV. You can see there is so much of variability. So that again points out the futility of trying to apply fertilizer in any predetermined ratio. And you have to take into account the variability, even in the same field of land or in a couple of fields, farm areas, for example, there is so much of variation of available boron, available zinc, available sulfur, phosphate, nitrogen, organic carbon, so on and so forth. The next slide shows the data on soil test. Perhaps I have been able to establish the fact that the potassium is very much of a neglected nutrient compared to its uptake by the crop. We do not apply it. We do not even prescribe it. It is 4:2:1. And the farmers even do not apply that much. They add even lesser. You remember that curve I showed you, the blue and the red lines. Now, the total number of districts is given here, the low in 76 districts. The number of the values in this is number of percent samples under each category that is studied. Medium is this much, and this is a 2002 map by Hassan. The low is this much. This is low. Medium is this much, and high is here. This is in 2002. Now, compared to this 2000 earlier data, which was in 1980, the Hassan's data show that the low and the high categories have decreased by 0.6 and 6.4%. Respectively, the high category has decreased so much, whereas the medium category, fertility status of potassium, increased to 7%. So it is necessary that such kind of soil testing processes are continued at definite intervals and periodic intervals, so that we know that where do we stand. Next is these two curves show you that the potassium balance that is applied as fertilizer and manure minus crop removal in 2007. This side, left-hand side, right-hand side is 2011. You can see in UP minus 735. This is the ton multiplied by 1,000 tons, negative balance of potassium. And Punjab and Haryana, for example, the food bowl of the country, as we all know, This is also highly negative. But when you come to 2011, they have become more negative. That means, excuse me, as I told you earlier, that the rather, uh, I mean, hybrid varieties of wheat, rice, vegetables, of course, they are being introduced in large amounts and so in considerable quantities. And as a result, the negative balance has increased. For West Bengal, of course, we have in a rather happy situation. It's not negative here. It is the green color is not negative. It's more or less the same between the two periods. What is more dangerous that you are losing? For example, if you have a bank account, let me just show you this. If you have a bank account, for example, say a fixed deposit you have, and you have you have a savings account and you have a current account, and there is an arrangement which is made that when the current account is depleted by withdrawal of cash, there is an automatic arrangement that from the savings account, the money will come to fill up the current account, so that you do not see, you think that the current account is being maintained. But at the same time, you are losing money from the savings account. If you do not see how much is left in the savings account, a time may come when there is nothing left in the savings account to take care of replenishment of the current account. Exactly that what you do in case of potassium. The neutron normal ammonium acetate test at pH 7, that gives the plant available pool. That means the water soluble plus exchangeable potassium. It doesn't give any idea about non-exchangeable potassium, which remains in the interlayer space of the micaceous minerals, and that is not measured. For measuring that, 0.1 normal nitric acid accessible potassium has to be measured, or in successive extraction with boiling 1 normal nitric acid will be necessary. That is not done in the soil laboratories, be it mobile or the static soil testing laboratories. So we do not know. This non-exchangeable potassium reserve acts as a kind of savings account. So we do not measure it. We do not know how much is left. So therefore, non-exchangeable potassium, this I have written is NEK, is not measured during the soil testing process. All the measurement is very simple. You have an additional extractant, 0.1 normal nitric acid, boiling normal nitric acid. You extract the soil for 10 minutes, and then you measure. The same flame photometer, but somehow it is not integrated in the soil testing laboratory so far. Therefore, continued undetected depletion of the elytic interlayer K, the micaceous or hydrous micaceous minerals, may lead to irreparable collapse. When there is so much of loss of potassium from the interlayer space, so that lattice itself will collapse, and that leads to an irreparable damage to the soil fertility, and which we will not even know. But as I told in the very first slide, that you have to increase the productivity. For increasing productivity, you have to maintain or perhaps augment the fertility. So if the soil is depleted so much, then how can you maintain the fertility so that you have the productivity goal attained, and hence you attain the food security issues in the country. Now, the point I was raising just now is shown here by these thematic GIS maps. You see, this is the available K, the one at the top, and one at the bottom is the non-exchangeable K. Available K means, as I already told you, the exchangeable plus non-exchangeable, exchangeable plus water soluble K. The lighter areas are the lower values, and the darker shades are the lighter shades are lower values, and the darker shades are for the higher values. So this is available K, and you see this is very high here. come to non-exchangeable K, it is low. You see it's fading. This is fading here. But we will not know because we measure only the available K. So not only that, we add less of potassium, and potassium supply is maintained by that reserve sometimes, and that reserve also we do not measure. So without our knowledge, we'll be losing money from the savings account. So a day will come when there will be nothing left in the savings account to take care of the current account fill up as a result. Now, why do we do this? We believe that the Indian soils have high inherent potassium supplying capacity. That means they are high in marquishes elatic clay minerals. And this has been the often repeated argument behind not applying adequate potassium. Let us see what the situation is like. For example, what are the mineral sources of potassium? Is the trioctahedral mica. The trioctahedral micas, biotite, for example, are more weatherable than the dioctahedral micas, which is muscovite. Biotite could be fluopite, also margarite, for example, the calcium one mica, and brittle mica. Biotite mica is called the black mica, and white mica is the muscovite, dioctahedral micas. Trioctahedral micas more weatherable than the dioctahedral micas. Any soil science student will know this. And the feldspar, these are the potassium sources, but they contribute very little to available potassium in the soils than the micas. Now, once you see, this is the equilibrium I was telling you. The non-exchangeable K fills up the exchangeable K pool, and it comes to solution. But when it comes to soil solution, it is not only the plant that will take up the soluble potash. It goes to leaching, it goes to refixation also. Therefore, release potassium from the structural positions to soil solution is not only a very slow process. Besides, there are several, competitive processes working simultaneously, so that there is no 1:1 congruence. Whatever is coming to the soil solution from this source, this goes only to plant uptake. No, there are competing avenues. Next one gives the exit intensity ratio of the peak heights of, these are the diffraction patterns, 001 plane over 002 plane, the basal reflection in silt and clay fractions of several Ildian soils. This is the silt fraction and this is the clay fraction. Now, if the ratio is 1 of these two reflections, then it is believed that the mica is dominated by muscovite, which does not give any potassium, less weatherable. Why it is so? Because for the trioctahedral micas, the intensity at 002 plane is very small. So if it is very small, then it will be almost 001 plane muscovite and 002 plane muscovite. So it will be 1 ratio. And if the ratio is more than 1, then obviously you assume that there is both muscovite and biotite at present. And as I said, biotite is more weatherable to release mica. You can see that for silt fraction, it is more than 1 in all the cases. In different soils, this is Indo-Gangetic IGP, Deccan basalt alluvium, DBA, black soil, granite gneiss or ferruginous soils, GG, this is the one, and Brahmaputra alluvium is this one. So for silt fraction, it is more than 1. So it is both muscovitic and biotitic. But when it comes to the clay fraction, less than 2 millimeter, you can see that this is 1 for these soils. So they are not good providers of potassium. Only the clay fraction of IGP and the clay fraction of this this is also this is also rate. It's close to 1. For these ferruginous soils, they have got biotite in them. This is all I have already told you, that the ratio equal to 1 suggests the presence of only muscovite. I explained the reason, because the 002 reflection is very weak in trioctadal mica, so that it is 1 for the dioctadal micas. Now, not only this is an interesting result. When I was at Bidhan Chandra Krishi Vishwavidyalaya, we did work on a bit of work on potassium as well. This shows that an anti-sol at Kolani, for example, and seed farm, and this is Anandapur. This is in Midnapur district. Laterite soil, the alphisol, and this is an anti-sol. You can see that the elytic mineral, which is supposed to be potassium source, because in the interlayer elytic layer, do I have time?
Yes, sir. Yes, sir. Definitely.
And you see the elytic mineral is more or less the same, 38.0% and 38.8%, at both the places, at Kolland and Anandapur. But when we come to the non-exchangeable potassium, that means that savings account kind of source, the reserve source, it is high at Kolani, but it is very low at Anandapur. Why? Because the native K status is a function of the parent material of the soil. Not only it's a function of the parent material, that is, it has to be micaceous, for example, but also subsequent stages of weathering. In an alphy soil, weathering has taken place so much that the interlayer interlayer space has wedge zone, as it is called. It has opened up so much that potassium has been lost. So therefore, there will be very high response to potassium application at Anandapur, not so high or little at Kolani. Therefore, basic consideration of not recommending adequate potash rates for crops while tapping the supply from the native elytic mineral sources may not hold good in the current intense agricultural scenario. This is Dr. Supratik Ghosh. He is now the Assistant Director of Agriculture in Kuch Bihar district presently. This is the potassium requirement of different crops grown in several different soils. The soils are given here, location in different places in the country, and the crop rice, wheat, maize, and gram. You see that potassium requirement in kilogram per ton is shown in the last column. Now, this is the highest requirement and this is the lowest requirement. The varieties, of course, are different. So the difference is roughly 20 ton per hectare. This is about 20. This is about 19, say, for example, or it's about 40 or thereabout. It's about almost 20 tons difference. Similarly, for wheat, this is the lowest value. This is the highest requirement, potassium. Then for maize, these two, and for gram, these two. Therefore, potassium requirement of rice that we have just mentioned varies over about 20 kilogram per ton. Now, they had, as I told you in the last slide, that different varieties are used. But this cannot be attributed to only the varietal difference. The potassium supplying capacity of the soils, that means which we know that is given by the mineralogy, particularly clay mineralogy, that seems to play a role. Therefore, the present trend of applying potassium at a certain predetermined rate or ratio should be examined closely. Now, we often say that the potassic fertilizer is imported, therefore, because we do not have muriate of potash deposit, So the poor farmers, because they are marginal farmers, having land holding less than 1 hectare for about 85% of the farming community in the country, perhaps little less in West Bengal, where there is irrigation facility, for example. This is poor farmers perhaps are less. And so that they don't use the potassic fertilizer. But that is not true. You see, these are the three cereal crops taken, including maize, which is potassium responsive crop. This is the yield with no potassium, yield with potassium, and the rate is this 60, 100 kilogram potash per hectare yield increment, and certain value has been assumed here, reasonable value. So there is, if one invests 1 rupee in purchase of potassic fertilizer, he reaps 5.5 rupee per rupee investment. So it is, economics is favorable. But because of, as I said, lack of awareness and lack of policy perhaps as well, the potassic fertilizers are not used. Now this is similar, this is the return on investment, is ROI for potassic fertilizer in case of pulses and oases at different kind of yield response that we want, 275, 381, and 600 kilogram per hectare. You see, there is always return on investment is more than 1 rupee. That is rupees per rupee investment in potassic fertilizer. And as you attempt more and more kind of response classes, you reap more and more benefit, 10.3 to 4.2 to 22.4 rupees per rupee investment in potassium. Now, there comes a kind of interlayer. Even if we assume perhaps that is true, that the potassic fertilizer is difficult to purchase it, the research for farmers, although I have just shown that even if you apply potash, you get benefit in terms of cost benefit ratio. Now, this is a potential approach for improvement of crop potassium utilization efficiency. This is now, if utilization efficiency of the increases, then of course we have more potassium utilized for but we know that at increase in potassium use efficiency of crop varieties, therefore it will help to counter the K deficiency problem. And the potassium deficiency is so high as we have just seen. Now the different plant species and even the varieties of the same species like genotypes, they often possess varied K acquisition and utilization efficiencies. Therefore, there is possibilities for selection or genetic modification of crop potassium nutrient efficiency. We can have these issue examined not only from the soil science or agronomic point of view, the crop improvement, the breeders, for example, or for example, the biotechnological issue approach may also be used to improve the potassium use efficiency. Now, this plant potassium use efficiency depends primarily on the capacity of the root to take the potassium from the soil solution. And that depends greatly on the root architecture. And this potassium uptake may effectively, if the root architecture is improved, the root K uptake activity may also improve the potassium use efficiency. Now, the potassium use efficiency is also regulated by potassium transport and translocation in the plant tissues and organs, which opens up the possibility for improvement of plant potassium use efficiency through genetic means, the breeding, the conventional breeding, as well as the biotechnological kind of tissue culture kind of issues in selected crops. Therefore, selection of important natural variations of the QTLs the quantitative trait loci here in crops associated with high potassium use efficiency may provide valuable information for genetic improvement of the crops. Now, this slide gives the candidate genes for improving potassium utilization efficiency in cropland. Now, I am not a geneticist, so if you ask me a question on this, then I will not be able to answer. But I thought that this information should be integrated. These are the nutrients, this is the gene of the Q-trien, this is the species rice, maize, and soybean, and how they function. The upward transport of K from roots to shoot, that is important. If they remain in the root, it's of no use. Also the K uptake channels and these symporters and so on and so forth. So the genetic approach may also be used to improve the ability of the crop to take potassium from otherwise inaccessible potassic sources. Now I come to the finishing part of the lecture. These are the various points we might think about it. Now, while it will be necessary to rationalize the use of nitrogen and phosphatic fertilizer, the signs are that if the potassic fertilizers are neglected, like in the past, then the Indian agriculture will be likely to be considered mostly by these nutrients. The potassium region supporting high intensive cropping sequences. I didn't mention one thing. I should have mentioned earlier that I showed you that there is a declining fertilizer response ratio. The as I shown you between 1970s to say 2015 or 20. Now in the IGP, Indo-Gangetic Plain, right from Ludhiana down to Barakpur, in the rice wheat cropping sequences, under the LTFE, the long-term fertilizer experiment of ICAR, the AICRP, the important organic fractions, the organic matter, there is increase in soil, there have been increase in soil organic matter as well as the important organic fractions. This has been studied by Dr. D.K. Pal, Dr. Tapas Bhattacharya and their colleagues at Nagpur, National Bureau of Soil Survey and Land Use Planning. They found that during this 25 years period, 1980 to 2005, there has not been any decline in the soil organic matter. Rather, there has been some buildup. Obviously, in the Indo-Gangetic Plain, in the intensive cropping sequences, so much of root biomass is left, so there will be increase in. So, increase in organic matter and important organic fractions. So, if we think that there is global warming and therefore organic matter decline is taking place, then that is not perhaps true. However, these workers, these scientists, Dr. Pal, Dr. Bhattacharya and their colleagues, they also noted that during this period, the soil inorganic carbon, that is calcium carbonate, that's also increased. That denotes the soil infertility. But anyway, the soil organic fraction did not decrease. So why then the potassium, why then the partial fertilizer factor productivity and the total factor productivity is declining? There must be some other reasons, the other factors that cause this declining. So I thought that perhaps potassium mining, nutrient mining in general, and in particular for potassium, and also for micronutrients, as I showed you, except for zinc, we had too much of zinc, so the zinc toxicity symptoms and the phosphorus deficiency is taking place. So it's not that the organic fraction is decreasing. So there must be some other factors. Unless we know these other factors, we will not be able to restore the response ratio, and as a result, the productivity will keep on decreasing. And next is the, as I was telling you, just a minute. Hooghly district, for example, as you know, is the second largest producer of potato in the country after the Farrukhabad district in Uttar Pradesh. And the regions supporting the high intensity cropping sequences as well as potash loving crops. For example, we all know that potato is a potash loving crop, and also maize is potassium responsive crop. This continuous cropping with only nitrogen phosphorus with no and inadequate potassium application would cause depletion of the non-exchangeable K, the reserve K, the savings bank account, which we do not know because we do not measure it. And that will go largely unnoticed by the conventional soil test for potassium. Next slide. Now, the potassium fertilizers are imported and therefore non-exchangeable potassium depletion takes place in our practices because fertilizers are perhaps expensive, although I have shown you that it's cost effective. Judicious site-specific nutrient management strategy has got the potential to address these various points that I have been pointing out. But here again I come back to the conclusion, I come back to the ratio. Why there should be a ratio after all? Why there should be a constant ratio for all crops, all soils, all climatic situations? So that is artificial in my opinion. The alternative K sources, for example, microbial mobilization of potash from the waste mica and tapping potassium from glauconite, which is of marine origin, is called green mica, green in color deposits, may also be considered. Potash contribution from irrigation water and top residue recycling, etc., will also be necessary. The mining of secondary and micronutrient also requires careful monitoring. And therefore, in future, we'll have to recognize spatial variability of the nutrient among farmers' fields and tailor our recommendations accordingly to improve the productivity. Next comes how to assess the nutrient mining. For this, a national soil portal for soil data repository is a critical requirement. There are fragmented databases maintained by different authorities, for example, the state government, the central government, and various fertilizer association of India, etc. These fragmented databases maintained by several organizations, which sometimes are unavailable in the public domain. They have to be integrated. They have to be integrated into one national portal for tracking these soil fertility changes and nutrient mining and all those issues. However, if we have data coming from different sources, then naturally you will have some concern about the quality of the data, whether how much of care went into finding out or analyzing these samples. There could be a national committee to oversee this data input with particular reference to data sources and the data quality. And this national soil portal therefore strongly fits into the current initiative, as you all know, Honorable Prime Minister's program, the Soil Health Card, for generating the soil health card for millions of georeference farm fields. Now, what is the take-home message? Now, I must admit that the kind of nutrient mining I was describing cannot be avoided altogether. But there is inherent buffering capacity and vulnerability of the soil. That means somebody's savings account will have large amount of money and the poor man will have small amount of money. So a rich man will have more capacity to withstand continuous withdrawal from the current account, that is potash removal by the crop and the loss avenues, whereas a poor man will have a less capability to sustain. It will collapse. Similarly, different soils have different buffering capacity. Therefore, the vulnerability of soils will vary considerably. And for this, perhaps there is a need for assessment of allowable range of nutrient mining under variable climatic soil crop management domain at the regional scale, which I have chosen to call a so-called vulnerability index of the soil crop system. Now, this particular talk, I intend to bring into our collective wisdom a kind of that it is a threat to health of soil resources and the food security concerns for the present time as well as for posterity. This is the indeed, there could not be, we cannot overlook the obvious. There are no substitute for or shortcuts to inadequate and balanced crop nutrition. Now, you see, this man is triggering his rifle. The deer is there, but he thinks the deer is somewhere there. So he is misguided. So we'll be also misguided. And this is George Bernard Shaw's famous kind of quote: "Science never solves a problem without creating 10 more." And thank you for your patience.
Thank you very much, sir. It was great information, and really you gave us a way how to think. Means specifically we are working on different issues of soil fertility and how we should approach these issues. So before any other comments, I will request from all the listeners, students, faculty members, if you have any question, you can ask our sir one by one. Please feel free to ask him, because you will never get this opportunity again to see a man who has been working in our soil science. I will say he's a stalwart, so please don't miss. We are fortunate enough that we were able to attend his classes, but specifically I will ask the PG and PhD students, those who have not attended his classes, please feel free to ask him questions. Then we'll ask, of course. Anybody from the students, please feel free to ask him anything. I think faculty members, please come up. Anybody from the faculties?
Okay, just to initiate the discussion, first of all, I want to thank Professor Sanal for his excellent presentation, which was very informative for us. And I think the way you have shown for further research program to be taken for our university and the outside campus, that will definitely give the way for us to take up the program in future. And the slides you have shown were very much informative for us. And we must look into those aspects which is still unattainable so far, particularly in case of nutrient mining and with respect to the potassium or phosphorus mobilizations. But it's not a question, sir. Just I want to ask your comments on this, that you have mentioned that there is declining of the partial fertilizer productivity, as well as particularly for those regions where there is less potassium bearing minerals, and the farmers are not advocating potassium fertilizers as per the requirements of the crops in some of the places of India. So in that cases, what should be our strategy as a soil scientist, so that the potassium fertilizer, which is most neglected fertilizer, as you have mentioned, compared to the others, that can in turn help for the building up the potassium nutrient as a nutrient in the soil, as well as that will help the yield of the crops in those regions where potassium is very less.
You see, I mentioned about Anandapur and Kolani, which is Kolani is an anti-soil, alluvial soil, rich in micaceous minerals, whereas the altisol or the altisols, incidentally, India doesn't have any oxysol. You have the oxic horizon, but you do not have any oxysol. I already shown you that if you carefully manage your potassic sources judiciously, the cost-benefit ratio, the amount of money that you earn by selling, by utilizing by investing 1 rupee, you reap 5.5 rupee, for example, for rice. For pulses and oils also, we have the benefits if you manage your soil properly, the soil resources properly. For example, in a light texture soil, obviously you will go in for split application, say half or perhaps 1/4 at the as the basal, and then split application, the 1/4, 1/4. For example, at the panicle initiation, then at the flowering stage, and so on and so forth, for say rice crop. And the irrigation water, for example, it contains many a time and considerable amount of potassium, but you have to manage it properly. In the light texture soil, much of it will be lost, as I have shown you. And there must be the alternate fuel for that. There must be arrangement, and without a government's active participation, this cannot be done. Of course, the providing the rural people with alternative source of fuel. For example, the biofuels, which is also coming up these days. The biofuel, the crops, for example, then these are the alternative fuel that you, or for example, the gobar gas plant. For example, Gujarat was quite successful in demonstrating that this cow dung plant was successful in providing the power to the rural people. Then harnessing the solar, this power, for example, that is also important. And management of potassic fertilizer, you split, you have mixed cropping, you have the potassium responsive, for example, a cereal, and whether you can have a legume in the mixed cropping, and these various issues, as well as tapping the alternate potassium sources, including the green mica. As I mentioned you, there is considerable amount of deposit of green mica, glauconite, and glauconite is more witherable. That potassium is easier to access. So it is not that if you use potassic fertilizer, you lose. If you use it judiciously, you gain in a cropping sequence. For example, West Bengal produces hardly 20% of its pulses requirement. And we know that there is a lot of this rice fallow. Those are being put to about 11 million hectares is the rice fallow region in the entire country, and quite a considerable not amount, the area is about 11 million hectares. And in West Bengal also you have that. For example, in the lateritic belt in Purulia, Bankura, Midnapur, the lentil, or in the coastal region, the lentil, for example, can be taken. And this way you integrate the crop and cropping sequences and manage your resources judiciously. I'm not quite sure whether the postgraduate students here, they are familiar with what is called the quantitative evaluation of fertility of the subtropical, the QUEPS model. Are you familiar? QUEPS model?
Sir, some of the students are working on that at postgraduate levels, not all.
I would like to know from them one thing, which is bothering me very much. In the QUEPS model, when you have the plot of the internal efficiency, I mean the grain yield versus the nutrient uptake, then you have a envelope of graphs. For example, a straight line surrounded by some on the top and bottom envelope. Now, which curve of the envelope is to be chosen to decide the fertilizer doses? This I have been wondering, and I have written also earlier. And in the next issue, the special issue of Fertilizer Association of India, the Indian Journal of Fertilizers, their special issue is, as you know, it comes in December, the annual function. There will be a paper by us on potassium, examining it from all points of view. There, all these information are integrated.
Thank you, sir. Thank you very much, sir.
Any other question?
Anybody from the house, Dr. Kamang, Dr. Dev, you would like to ask questions? Please come here, please. Do not catch up, otherwise it will catch. It will catch. Okay. Continue. Dr. Dev, please.
Sir, thank you for your very nice lecture.
Thank you.
You have elaborately described about the imbalance use of fertilizers for the reasons for the nitrogen mining in the soil. Sir, what are the strategy to input the potassium use efficiency in the soil? Actually, not doing all.
I don't get you. What is the strategy for?
Sorry, sir. Strategy for phosphorus use efficiency in the soil.
You see, phosphorus deficiency is also widely spread. As you know, the phosphorus is both in the acid region and the alkaline region. But for phosphorus, you have one comfort, that phosphorus doesn't leave. It stays in as reaction products of various degrees of insolubility in the soil. The use of biofertilizer, for example, the phosphate solubilizing bacteria, and there are fungi also. And as you know, that this VAM, for example, the vesicular mycorrhizal fungi, they are also able to mobilize the otherwise insoluble potassic sources for the plant uptake, and the biofertilizers, they can be used. But the benefit of biofertilizers is very well known, is well established. But it has not had not caught up with the imagination of farmers, simply because of the fact that the cell life, the kind of the longevity of the organisms which mobilize the phosphorus, or for example any other such biofertilizer, by the time it reaches the farmer's door, half of the strains are already dead. The shelf life is 3 to 6 months only. So it's a kind of issue that must be addressed not only by the university, by the KVKs, also under the university, the ICS system, as well as the government, the nodal departments. They must be sensitized so as to mobilize phosphorus. Otherwise, phosphorus is also a problem. But there is a kind of solution that is possible, that it can mobilize phosphorus. And potassium you cannot, because it is lost. It goes, it gets, it leaches out. So you don't have so much of potassium left. And most importantly, I will recommend that in the soil testing laboratories, there must be non-extendable potassium measurement. You have the flame photometer, so you don't need an extra equipment. You need only an extractor extracting. That is also very cheap. For example, the concentrated nitric acid that you have, it is 16 normal in the bottles. You can have 1 normal boiling or 0.1 normal boiling acid. So only 10 minutes extraction. At least once in an intensive cropping sequence where you have 300%, 250, 300% cropping intensities, there the non-extendable potassium must be measured at least once a year to see to it how much of potassium is lost. And it's not only potassium, all micronutrients except zinc. Zinc has been built up to a toxic level, as a matter of fact, because of continued application of zinc without zinc sulfate, and also various calamine and all those kind of, the complex zinc fertilizers without testing zinc. So that induces toxicity. So phosphorus can be mobilized.
Sir, but the issue is that the farmers are reluctant to use the organics, particularly the ZSB, PSB, and sometimes the K.
No, farmers are obviously will be reluctant. That's why it has not spread to the extent desirable, because we lack in our system of delivering the biofertilizer in time. By the time it reaches the farmer's door, half the strains are dead. So a mismatch between the generation of the biofertilizer and its timely reach at the farmer's door is important. The benefit of biofertilizers is extremely well known, but it has not spread that much. It has to go to the farmers right in time. So that is important. That is why farmers are not perhaps interested. But if you keep on using the inorganic fertilizers only, you know that what will be that. For example, I give you one more data. You know the DDG Dr. S.K. Chaudhary of Natural Resource Management at the ICAR in 2015 was the soil year, International Soil Year. And as a result, the National Academy of Agricultural Sciences held a seminar and brought out a book that State of Indian Agricultural Soil in 2015. I was one of the editors, so 3 editors, Dr. Himanshu Patil, Dr. P. N. Thakkar, and Dr. Chaudhary and his colleagues had a very good article there on the policies. There he has shown that in 1970 to produce 2 tons of rice plus wheat in the irrigated tract of India, 84 kilograms of nitrogen, phosphate, and potassic fertilizer was obtained. But in 2013, to obtain the same 2 tons per hectare rice plus wheat, 280 kilograms of nitrogen, phosphate, and potash is taking place. That means there is a constant decline in, as I showed you, the fertilizer response ratio. Now, we cannot attribute it to only the global warming issue. As I have pointed out, that the soil organic matter fraction has not declined in many places in the intensive cropping sequences. But there must be some other factors. I was wondering that nutrient mining perhaps could be one of these other factors. Until and unless you are able to identify these factors, you will not be able to arrest the declining trend of the soil, the kind of soil fertility fatigue, as we call it. So these factors must be identified by the appropriate reasoning. Now, you are from North Bengal. You have seen the tea gardens in your area. Have you seen? You know that tea soils, the acidic soils, they have got zinc, the DTP extractable zinc, 0.005 molar DTPA at pH 7.1 by triethanolamine buffer. That goes up to about 20 ppm. I mean, about 2 to 22 ppm. As you all know, the critical limit is 0.6 to 1.2 ppm. But you know, in tea, until and unless you have zinc sulfate spray, the tea growth is stunted. So that means there being adequate amount of zinc being present in the soil solution, the tea is unable to tap that. Why it is so? While I was chairing the scientific advisory committee of the tea research station at Toklai, Jorhat, then I raised this issue. This has not somehow attracted their attention. It's still a mystery. Since you have the tea soils there, easily gathered, you will find that the amount of zinc. You have the acidic soils. The naturally zinc will be very high. But why tea needs this zinc sulfate? Really, the production gets hampered if you don't spray the zinc sulfate. Why zinc sulfate is necessary? Despite the fact that there is so much of DTP extractable zinc present in soil. So I wonder whether you have a kind of faculty of tea or faculty of forestry, for example, in your university?
Yes, sir.
Do you take care of tea, which is an important commercial crop?
Yes, sir. The Department of Forestry is taking care of that.
Crops they have.
You measured the DTP extractable zinc, that is 0.005 molar DTP, as you all know, at pH 7.1, buffered with triethanolamine. You find out the DTP extractable zinc. You will find that it's in the region of say 10 to 15 ppm. But unless you spray, the tea suffers, tea growth suffers. That is a fact. That is the agronomic practice. Why it is so? I don't know. Any other question?
Sir, in this imbalance issue, the farmers, the major responsibility is heavy with the nitrogen. Sir, the major reason is the heavy use of nitrogen fertilizers. The ratio is being 4:2:1. So in that case, government is giving huge subsidy on nitrogen. So government should take some initiative to reduce this subsidy so that the farmers purchase less on nitrogen. So in that case, it will be possible in future to lower down this imbalance.
Of course, the 4:2:1 to 4:2:1 ratio or 2:1:1 ratio, West Bengal is little better. That's why you saw that in West Bengal you do not have negative balance in many places. There is a positive balance of potassium. But in the Haryana, Punjab, Uttar Pradesh, Rajasthan, Madhya Pradesh, Chhattisgarh, everywhere you have the negative balance. Now, this, what did you say?
Subsidy on nitrogen, urea.
Yes, that at the policy level, people have to be, I mean, the policy level they have to be sensitized. Now, if they are not sensitized, in the lecture I have shown that the breeders can use the genetic approach to evolve the varieties, to breed the varieties, either by the traditional breeding or the biotechnological options, which have higher potassium utilization efficiency. That means they can harness more potassium even at a low potassium level in the soil. So here the beauty of the interdisciplinary study lies, and those approaches can perhaps be approached. Any other questions?
Good afternoon, sir.
Good afternoon.
Sir, I have a question, sir. Actually, I am a bit confused about the ratio that 2:1:1 that you told. Actually, I have been in the field of basically in the vegetable export zone. I have been in a farmer's field and I have recorded that even in potatoes, they used to apply more than 400 kg of urea.
That is loss, 400 kg of urea. And how much of potassium?
The potato is...
I don't know, how much of potassium?
Oh, potassium, that means 2:1:1. That means...
Now you know that the tuber bulking phase, for example, the 75 days to about 100 to 110 days, the tuber bulking phase, you need a lot of potassium, not nitrogen, right?
Yes.
So if you add 400 kilogram of nitrogen and only 2:1:1, that means about 200 kilogram of potash, right?
Yes.
But potassium that is needed, nitrogen leads to vegetative growth, not the reproductive part of the tuber. Similarly for maize, for the cob, you need potassium. So and the farmers overuse in potatoes. In many cases, they overuse the fertilizers. Therefore, the crop which follows the potassium, for example, sesamum. After harvesting potato in, say, February beginning, you can have sesamum crop. Sesamum, as you know, is that the oil you can have, and it is a very hardy crop. It needs only 20 centimeter or 25 centimeter of this irrigation, for example, and it is hardy crop. Its nutrient requirement is less, so you don't have to add any fertilizer because you have added so much in phosphorus. I'm sorry, in potassium, and you can have a crop, and then you'll have the oil out of it.
Sir, and another question, as Dr. Ganesh Bonik was asking, that on the part of planning, if you will get opportunity, or you may suggest us that farmers, they are so traditional. They particularly they will go with urea, DAP, and the 26. Whatever we told them.
What is urea, DAP, and?
10, 26, 26.
10, 26.
Yes. They are so traditional, I have seen. Sir, we cannot make their mind that you go for some customized like and boronated NPK and zinc coated. So in often and not only that, but there is a good scope of slow release fertilizer also. But if we go with them, these fertilizers, we can increase efficiency as well as we can reduce the pollutions, and also we can somehow we can manage this imbalance, negative your
Yes,
imbalance
that
of
is,
fertilizer.
it is for this reason you have the Directorate of Extension Education, the KVK system, the ICAR institutes, and the government. The
Yes,
government has to be. I mean, it's the job of the scientists to inform them what is the scenario at the ground level. And they have to be sensitized. Now, there are many other issues, of course, involved. You know that in subsidizing the urea, so it is better not to go into those.
sir, my actually question is, actually government is pushing very hard subsidy on urea particularly. So
Yes,
can
yes, you know that 92, 93, only potash and phosphatic fertilizer are decontrolled, not urea. Urea subsidy continued. That got even worse in what that worsened in 2010 with the NBS, based subsidy introduction. So neem coated urea, for example.
Sir, my
So
submission is, if you'll get opportunity or you are there in so many advisory committees, you just give forward our information that they can also give some subsidy on slow release and some customized fertilizer as equal subsidy on customized fertilizer and slow release fertilizer, so they can be attractive. Farmers can be attractive.
you know the customized fertilizers, they're the latest addition to this fertilizer sector. Yes, this is true, and this, you see, if you see the forthcoming article in the Indian Journal of Fertilizer in December, which will be out soon, I mean in December itself, you'll see that lots of suggestions have been made, but then the policymakers have to be sensitized. Now the Extension Department of the Agriculture Department, for example, the ADOs, for example, the ADOs, you call them assistant data of agriculture these days, in the extension general as well as in the research wing, they already know these, but they have to be sensitized. Otherwise, this lopsided policy giving so much of subsidy to urea only leads to that over use of nitrogen fertilizer that does not give any. But then you can have the genetic approach, the kind of photosynthetic, its effective transfer from the vegetative part to the reproductive part can be enhanced by the genetic approach. That is why an interdisciplinary research is necessary. And by the way, as you are based in North Bengal, I will request you to undertake a study to find out why tea is unable to take zinc from soil solution, despite the fact that there is so much of zinc present. The
Yes.
tea scientists whom I wanted to sensitize, somehow I failed, so I didn't. And also the role of aluminium in tea.
G.
Aluminium, what is the role of aluminium? I do not know for sure. Tea is an aluminium loving crop, is it not? And aluminium is toxic. It affects the root growth severely. In rice field, if you have a lot of soluble aluminium, then you have the 100 grain weight of rice grain will be much less, because much of it will be empty, chipped, is it not? So why tea loves aluminium, whereas other crops don't? You know, during my interaction with the tea scientists, and now I'm still interacting with them in the tea board, I found that there is little integration between the scientists working in the tea field and the scientists working in case of say cereals, in other commodities. So there, this kind of bridge is necessary between the agricultural scientists in different branches, working and the scientists working in the tea, not only tea garden, tea industries as well.
Thank you, sir.
Welcome.
Thank you, sir, very much for interacting with our scientists. Sir, I have only one simple question for you, because you are giving us lots of information what should be our approach in future. So I have one simple question. Other than potassium, what other elements we should more emphasize? Because potassium definitely needs some attention of our policymakers. But other than this, which other elements we can also, in for future perspective, we can go for attention?
I already shown you, Avash, in one of my slides, that the micronutrients, except zinc, boron, molybdenum, manganese, everything is going, the reserve is negative. The balance is negative. Boron is very important for the North Bengal soils, for example, in vegetables. So boron must be, and boron is coming up after zinc, the boron deficiency, all over the country. So that is an important nutrient. So it should be taken care of properly. Now for boron, there are several extracting solutions. You know, you have this hot water extractable boron, then potassium dihydrogen phosphate extractable, and so on and so forth. Do you have connectivity with IARI?
Yes, sir. In some of the students who were in this campus, they.
I urge upon you and the Bindu as well that you get in touch with Dr. S.P. Datta in the Division of Soil Science and Agricultural Chemistry. He's professor of the division.
Yes, sir. He was scheduled to give a lecture after you. So he has changed the date because of some preoccupied. Yeah. So he will be there in this webinar series.
When? Which day?
Probably on 11th of 12th November.
12th, what time?
At 2:30, sir, 2:30 p.m.
2:30 p.m.
Okay. He has been working consistently with the micronutrients in general and boron in particular. So I have gathered, since I was there an adjunct professor for 5 years, and before also I have had good opportunity of interacting with him. So hot water extractable boron is not a very reliable extractant any longer. So boron is an important micronutrient for North Bengal soils. And what other nutrient is important? You tell me as far as the deficiency is concerned.
Sir, actually, in this case, I wanted to bring to your attention that boron has been identified as a deficient element in this North Bengal areas. Naturally, farmers, they are adding it like anything. So now the problem has arisen.
What is the rate? What is the rate?
Rate, they just apply the 5 kgs, 10 kgs per hectare like this way.
There is no recommendation?
Borax. So
yeah, no, but there is no recommendation from the university?
No, university follows the same recommendation of what the government is following, because, sir, the problem is that we cannot recommend, farmers will not accept either agriculture
unless it comes from the government.
Yeah, that is the issue. So what we are seeing that, sir, boron is not any more deficient in some areas.
That is why I told you that you saw that zinc build up, positive balance so much. Yes, only once in say 10 years, perhaps sometimes it was deficient. So we keep on loading the soil and then to the toxic level. As you know, for the micronutrient, the difference between the deficiency, adequacy, and toxic level is very narrow. So if you keep on pouring without the soil test, at least at 2 years interval, then there will be a build-up, and that will interfere with, like zinc has done with phosphorus, for example. So this will be the case. Other than boron, which nutrient is important?
Sir, at present, we have one long-term experiment. There, actually, for last 2 years.
Do you have an LTAP center?
Pardon, sir?
Do you have an LTAP AICRP?
No, sir, no, sir. No. We were actually maintaining from collaboratively our department and the pathology department and agronomic department. We are maintaining this long term since 2006 on conservation agriculture. So there we found that this time magnesium and little bit sulfate we had faced problem. So in cereals, so rice wheat cropping system. So this has come up because the source of fertilizer we have been using, specifically that complex fertilizer 10, 26, 26. Sorry, fertilizer. So that is creating, that was elevated the pH and that resulted in this deficiency. So this is also happening in few farmers cases also. So lots of elements in our areas, other than these micronutrients, specifically the secondary nutrients, they are, I think, in future going to be an issue for our areas.
Now, sulfur is now called the so-called fourth element, fourth nutrient after NPK. And
yes, sir. Yes, sir.
Some of the slides I showed you that for sulfur also, the ratio, remember that dilution factor, the output-input ratio.
Yes,
more than
all were above one.
More than one at all the 10 locations, just like potash. But the sulfur depletion was less compared to potassium depletion. Anyway, sulfur has become and because we are going in for the, we have perhaps we are discouraging farmers to use the SSP. Nowadays, DAP is used. Now with SSP, the sulfur used to come. With DAP,
sir.
It doesn't. So if to have an optimum mix of these fertilizers, and 10, 26, 26 need not be the adequate one. So you have the fertility trials and with different sources as well as, and in appropriate statistical design, split pot design, for example, you can have and then find out those.
Okay, sir. Thank you, sir.
You're welcome.
Questions, students?
Sir, one question is there, Professor Sinha, from Shubhadeep Mondal. I can read the question.
PG student.
Shubhadeep Mondal is from which place?
Shubhadeep.
He's from BCKV.
He did his undergraduate from BCKV. Now he's pursuing PhD under Dr. Soubhik Dev, and he has done his MSc from our university, sir. So
yes,
has he applied? Did he apply recently for position at ISI, Indian Statistical Institute?
No, sir.
No, sir.
Sir, yes, put one question. For any GIS-based semi-empirical modeling, till now, we are getting low predictability for available phosphorus and potassium content. Is there any better approach to solve this problem?
I didn't get you. It is echoing.
For any GIS-based semi-empirical modeling, till now, we are getting low predictability for available phosphorus and potassium content. Is there any better approach to solve this problem?
If you have low potassium, you have to add potassium. That's why, for example...
Sir, actually his question is related to GIS and remote sensing.
GIS, remote sensing. Now, GIS, remote sensing, by the GIS is simply, it's kind of integrating different platforms of different properties.
Right, sir.
You have a GIS. The remote sensing, I'm not quite sure whether remote sensing will be of much use to delineate the deficient areas. Can you? I'm not sure.
I think Dr. Dev can enlighten a little bit in that aspect. Dr. Dev, please.
In this regard, sir, I will say to with your permission, sir, that you have already pointed out that non-exchangeable potassium is going to be a very important factor along with the method we are following in testing our labs for available potassium like ammonium acetate. So probably Shubhadeep, here we can use this, include this parameter and then correlate it with your remote GIS based modeling. Then it will be, I think, give you a good correlation what you are asking for. I think sir will more be, because he gave us a clear indication that non-exchangeable K is a very important issue in case of getting potassium along with available potassium.
Yeah, you see, as I said that at least once in a year where you have 300% cropping intensity, or at least once in 1.5 years, you don't need any extra equipment. You just need a very cheap extractor. Nitric acid is very cheap. So what is the harm in doing one more extraction? You must measure, as I said, that in the savings bank account, how much is left. If you don't know, and if you keep on withdrawing from the current account, and a savings account filling up the current account, at a time will come when there will be nothing left in the savings account, and then the system will collapse. So you must measure at least once a year. Now, any kind of modeling work has to go back to the field for field validation. Now, for modeling, what kind of modeling was he mentioning? The remote sensing and GIS.
Yeah, for any GIS-based semi-empirical modeling, till now we are getting low predictability for available P and K content. Is there any better approach to solve this problem?
Yeah, there is a better approach. The modeling also in the semi-quantitative manner. You know the journal Environmental Monitoring and Assessment? The journal Environmental Monitoring and Assessment?
Yes, sir. Yes, sir. We know it's a very high impact factor.
In 2015 issue, we have a publication there about this, including the kriging. So he may refer to that. If he writes an email to me, I can send a copy of the reprint to him so that he knows how to take care of that. We had a paper published there in 2015 regarding potassium. Now, if you have a low potassium, for example, you have to add potassium. For example, that in South Bengal, South 24 Parganas, in the coastal region, there is response to potassium to rice, which is grown in a submerged condition. And as we all know, on dilution, potassium comes into the solution phase. There is response to potassium even as at a very low rate of 20 kilogram of potash per hectare. That means unknowingly we have taken out so much of potassium from the soil. The potassium response is being noted even on dilution when you are supposed to have more potassium in the solution phase. So these are the areas, and as you rightly mentioned about the magnesium, I thought magnesium is very important for tobacco, is it not?
Yes, sir, definitely. It is important in jute also, sir. But now we are finding it important in cereals also.
Oh, yes, that would be then the second, as I told you, that the secondary and the micronutrients also, their monitoring is necessary. For the micronutrients, as you saw from one of my tables, there is a clear deficit, except for zinc, which is toxic, as a matter of fact, in many places.
Okay, sir. Thank you very much, sir. I think we can move on to the next or the last of our part of this webinar. So I'll request Dr. Amrit Tamang to give his concluding remarks.
No. Dr. Sinha, the concluding remark will be given by Dr. Bonik, and the vote of thanks will be given by Dr.
Okay, Dr. Bonik, I may request you to give your concluding remarks.
Thank you, Dr. Sinha. It's a privilege for me, and it is also a very tough job to conclude the lecture delivered by Professor Channel, who was my guide in the PG level. He has given a lecture on the issue of the nutrient mining. It's a very important issue to increase the crop yield, to achieve the zero hunger as postulated by the United Nations within 2030. So he has discussed about several aspects responsible for the nutrient mining. So in that case, he has very much explained about the imbalanced use of fertilizers, particularly heavy use of nitrogen, as well as the low use of other fertilizers, potassium, as well as the micronutrients, which is responsible for deficiency of the micronutrients as well as the P and K fertilizers in the soil. And Professor Sandal has very elaborately explained how we can decrease down this nutrient mining to increase the crop yield to achieve the zero hunger by 2030. So in that case, he has discussed about the several aspects, several strategies to improve the nutrient use efficiency, particularly for the potassium use efficiency, as well as to increase the phosphorus level in the soil. And he has discussed some case studies as well as some strategies which is applicable particularly for the maize rice system, and he has given some ideas as well as some strategies to adopt the site-specific nutrient management strategies to improve the nutrient mining, to reduce the nutrient mining and improve the nutrient use efficiency in the soil. And Sir has discussed a very important issue about the about relation between the soil mineralogy as well as the potassium fertilizers availability in the soil, which we have studied in the postgraduate level in the class of Professor Sandal. And after a long time, it was the recapitulation of our classroom knowledge, which we have got in the master's level in the Professor Sandal's class. So and lastly, he has given a take-home message that there is no substitute to increase the crop yield except to use the balanced fertilizers to use in the crop field, and we have to adopt different variability in the cropping sequences. We have to use the multiple cropping styles, and we have to reduce the soil vulnerability index to increase the to decrease the nutrient mining in the soil. And the discussion part was also very good. Except his topic, he has given us several points on which we can progress our future research, such as we should study. He has said that we should study the reasons for animal loving nature in the tea, as well as why the tea is not. Tea field has a huge amount of zinc, and tea is not uptaking the huge amount of zinc, which may create some problems in future. So he has given up us some idea, so that we can continue our think to extend our research in this field. Okay, thank you, sir. It's my privilege to listen to you. I'm excited to listen to you after a long time. Thank you, sir.
Thank you very much. Thank you very much. Thank you.
Thank you, Dr. Ganesh Bonik. So, Sir, you have rightly summarized what Sir has given us the message. And one very important thing Sir has highlighted, that we'll have to work interdisciplinary, that we have to work from here on. And now I will ask Dr. Amit Tamang to extend his vote of thanks. And Dr. Amit Tamang, please.
A very good afternoon to all of you. Thank you, Professor Sinha, convener of this lecture or series, webinar series. First of all, I would like to wish Subha Vijay to all of you, and my pranam, especially pranam to Sandal sir.
Thank you.
Because I still remember that I may be the luckiest one that I had completed one semester, one subject in your quarter only. I have taken one course I have completed in your quarter when you are director of research. So we have to run for the class early at morning in your quarter, sir. So it is really our opportunity that again we can hear you. So indeed, it is opportunity for me to pay a vote of thanks on behalf of the Department of Soil Science. Sir, really, we are energized, and we are really intensified with the knowledge of nutrient and plant nutrition. We really like to thank you for this lecture on soil fertility, basically soil fertility and plant nutrition. So on behalf of Department of Soil Science and Organizing Committee, I really like to thank you for this beautiful presentation or beautiful lecture. This is our first series of lecture. We have 5 steps of lecture, which will be continued till December 11. And we are basically covering all the aspects of soil core branches like chemistry, fertility, physics, soil microbiology, pathology, as well as environment and soil environment, land use and conservations. We have covered all these sectors. So thank you, sir, for this nice presentation, which will help us a lot to understand, as because the matter is very simple. Every department they can understand, but they cannot dug out the knowledge which is actually you have explored with pros and cons. Thank you, sir. And I would like to extend my thanks to Honorable Vice Chancellor of our university, Professor Dr. Chirantan Chattopadhyay, sir, to promote us and to encourage us to organize such kind of seminar from Department of Soil Science. Again, I would like to extend my vote of thanks to our patrons and different dignitaries, Professor Ashok Chaudhary, Director of Director of Research, and Professor Somin Mitra, Dean Postgraduate Studies, Professor Divendu Mukhopadhyay, Dean Faculty of Agriculture, and I would like to add some more vote of thanks to Professor Divendu Mukhopadhyay, because he is the man who is behind this seminar, organizing this seminar, because he is the all-rounder taking care of head of the department as well as coordinator of this seminar and also Dean Faculty of Agriculture. So thank you, sir, for such kind of initiative for development of our department and as well as for our university. And again, Professor Pradut Kumar Paul, Dean Faculty of Horticulture, for his support and provide again. Next, I would like to thank Dr. Rupak Sarkar, Dean Faculty of Horticulture, Dean Faculty of Technology, Professor Prabhat Kumar Pal, Director of Extension Education, and Professor Bidan Roy, Dean Student Welfare. Last but not least, I would like to thank on behalf of our department or seminar organizing committee to the electronic handling persons, electronic technicians, those who are handling this classrooms, all the staff of this entire VC office, and of course, without their participation or without their attendance, we could not have achieved this feat, or we could not have achieved this succession. I would like to thank all the participants on behalf of our organizing committee. And I would like to thank again coordinator Professor Divendu Mukhopadhyay, convener of this committee, organizing committee, Professor Avas Kumar Sinha, joint convener of this seminar, Dr. Ganesh Chandra Banik, and members Sovik Dev, Kapudeep Karmakar, Tapas Kumar Pandit, and Mr. Hirde Kumar Tarafdar. So with this vote of thanks, if anybody is left with them, for them also, a lot of thanks for this seminar, or to support this seminar. So with this vote of thanks, now may I like to request our convener, Professor Awasina sir, to conclude the session.
Thank you, Dr. Amrit Tamang, for your remarks. Okay, so today, on this day, we will be ending this webinar, sir. Thank you for joining us. Thank you for enlightening us, sir. Thank you very much. Stay healthy, sir, and give blessings to us so that we can go forward in doing your research, and we'll be keeping in contact with you, sir. Thank you, sir.
But don't forget the tea. Don't forget the tea.
Okay, sir, we'll not forget. Definitely somebody among us will take up the tea issue.